Hello everyone, I'm Liguang Zhou, a PhD candidate from the Chinese University of Hong Kong, Shenzhen. I'm also working at Shenzhen Institute of Artificial Intelligence and Robotics for Society. I'll present an IROS 2021 paper, BORM, Bayesian Object Relation Model for Indoor Scene Recognition, in this video. The presentation mainly includes these 6 perspectives. The right figure shows the 7 categories of indoor scenes from the Places 365-7 dataset. First, it shows that indoor scenes consist of rich objects. Second, different scenes have different scene-specific and scene-common objects. Therefore, an essential and effective semantic representation of indoor scene should be developed to describe the indoor scene with object features and object relationships. Question: how could we utilize the object features and object relations to describe the indoor scene? Can we enhance the presentation of scene-specific object pairs while suppressing the scene-common object pairs for indoor scene recognition? As shown in the right part, the bed and lamp are a scene-specific object pair of the bedroom, while the wall and floor are a scene-common object pair, which appears in each place with the same probability. The left figure uses the Bayesian filtering method to model scene recognition problems. However, it lacks the utilization of semantic information and is without the modeling of object co-occurrence. The right figure makes use of object detection to incorporate the semantic information with Bayes' rules. Nevertheless, it lacks the modeling of object co-occurrence. The left work uses a multitask training scheme to boost scene recognition performance yet lacks explicit semantic information and object relation modeling. The right work shows the object model and CNN used for scene recognition. Still, the object relation is not studied. The left work uses the spatial-to-spatial relation for scene representation with an RNN model, and the right work uses LSTM to learn the object-to-object implicitly. In summary, both of them have not studied object-to-object relation in a Bayesian probabilistic manner that statistically lists the relation among object pairs over various scenes. In this paper, we propose a Bayesian object relation model that explicitly models the relations of object pairs among various scenes, in which we highlight the scene-specific object pair while suppressing the scene-common object pair for scene recognition. We use Bayesian equation to analyze the probability distribution of the object pairs over different scene categories statistically. From the left figure, we observe the posterior probability of scene given object pair bed and curtain has a large standard deviation, 0.30, and has the highest probability in the bedroom. The bed and curtain form a scene-specific pair. The posterior probability of scene given object pair, wall and floor, has a small standard deviation, 0.01, and the probability of object pair appear in different scenes is similar. The wall and floor forms a scene-common object pair. We define the standard deviation of posterior probability as the Bayesian relation value to describe the relation of object pairs to the scene. The right figure shows the Bayesian object relation matrix of first 20 objects in the IEEE. The value in the matrix represent the standard deviation of posterior probability across different scene categories. We combine the proposed BORM and Places CNN with backbone ResNet as the combined Bayesian object relation model. We use an improved object model as the baseline, based on a scene parsing algorithm pre-trained on the IEEE dataset that contains more relevant object classes for indoor scene representation. The dataset used for evaluation is shown in Table I aims to test the generalization ability of the proposed algorithm. The training set of Sun RGBD is based on the Places 365-7 dataset. The ablation study of the baseline model is shown in Figure 6. As the number of object classes increases, the performance of the scene recognition also increases. Surprisingly, the IM baseline surpasses the object model with over 20.5% accuracy on average. The Table 2 shows the results compared with the state-of-the-arts on the Places 365-7 dataset, and Table 3 shows the performances on the Places 365-14 compared with the state-of-the-arts. The combined Bayesian object relation model, BORM, significantly outperforms the state-of-the-art methods on the Places 365-7 and Places 365-14 dataset about 2% accuracy, and Sun RGBD, unseen dataset without retraining the model, showing the excellent generalization ability of the proposed method. This demo shows the real-world experiment with a mobile robot traveling by an office building. In conclusion, we utilize an IM as a strong baseline based on the scene parsing algorithm pre-trained on the ANTE-20K dataset containing more relevant object classes for indoor scene representation. Undoubtedly, the IM baseline surpasses the OM by a large margin. To conduct an in-depth study of object pair relations, we propose a Bayesian object relation model, BORM, that probabilistically enhances the scene-specific object pair relation and suppresses the scene-common object pair relation for indoor scene representation. We combine the proposed BORM and the Places CNN model as BORM, which significantly outperforms the state-of-the-art methods on the Places 365-7 and Places 365-14 dataset, and Sun RGBD dataset without retraining the model, showing the excellent generalization ability of the proposed method. Thank you for your listening. The code is open sourced, and you can either type in the website or scan the QR code for further information.